Okay, let's check our answer from slide 26. Hopefully you all got 7499 says equal to 0.74 repeating. Remember, we always want to double check if this is in simplest form. So one thing you always want to double check is the divisible by 3 rule. Remember, if you add up all the digits in the number, like 7 plus 4, so what's 7 plus 4? That's right, 11. And if that number is divisible by 3, then the whole number is divisible by 3. So is 74 divisible by 3? No, it's not, because 7 plus 4 is 11, and 3 does not go into 11 evenly. Okay, let's take a look at our next slide. So the next slide we have 2.4 repeating. So we have two options here. We can think about this as x set equal to 2.4 with just the 4 repeating. Or we can think about 2.4 repeating being 2 plus 0.4 repeating and just deal with the x. Sometimes if I do this version, I'll forget about adding the 2 at the end. And since we want our answer to be a simplified fraction, we don't want to have a mixed number. So I'm going to stick with setting x to equal to 2.4 repeating. Okay, how many decimal points, how many decimal places do we need to get rid of because we have one digit repeating directly to the right of the decimal point? That's right, 1. So what do you think we should multiply both sides by? Well, let's try 10. Let's multiply both sides of our equation by 10. Let's see. So we have 10x is equal to 24 point, remember this is 2.44444444. So this is 4 repeating. So when we subtract, cancel out 2.4 repeating from this side, that's equal to x. So I'm going to subtract x. That means I'm subtracting the same amount, making this still equivalent to each other. 10x minus x is 9x, and 24.4 repeating minus 2.4 repeating is going to get me 22. Okay, so now I need to divide both sides by 9. And I get that x is equal to 22 over 9. So notice that is the same thing as if I thought about how many times does 9 go into 22. 9 goes into 22 twice, 18. With 4 remainder, it's 2 4/9. So it's very interesting to think that 2 4/9 is the same thing as 2 plus 0.4 repeating. Do you see any patterns yet? Well, maybe we will with the next slide. So let's go ahead and look at the next slide and write down in our notebook the next decimal, repeating decimal, rational number that we are writing as a fraction. So we have 105 thousandths repeating. So 105, 105, 105, 105, 105, 105, 105, and so on. So what's our first step? You're right, we're going to set it equal to x. How many digits are repeating here? There's 3. So if we multiply by 10 or we multiply by 100, we're not going to have the repeating decimal part line up properly to subtract. So we're going to have to multiply both sides. That's right, by 1,000. We got this. So when we do this, we have 1,000x is equal to, move the decimal place over 3 times, 105 repeating, which is great because now we have this repeating decimal isolated over here, and I can just subtract what I had set equal to x on both sides. So now I will have 999 x's is equal to 105. Now divide both sides by 999. And I notice that x is equal to 105 over 999. Again, think about your divisible by 3 trick. This is the unsimplified version. 1 plus 0 plus 5 is 6. 3 goes into 6. 9 plus 9 plus 9, 27. 3 goes into 27. So I'm going to divide my numerator and my denominator by 3, and what do we get? We get 105 divided by 3 is 35, And 999 divided by 3 is 333. So let's see if we can do it again. 5 plus 3, well, that's 8, so 3 doesn't go into that. So this is our final answer. But I do want us to look at this just so we can think about looking for a pattern. So let's look at slide 29 and see if we can find a pattern. Let's fill in this table together. So remember, 0.5 repeating, and we're going to be looking at these unsimplified, was 5 over 9. 0.74 repeating was 74 over 99. And 2.4 repeating, you can look at that, it says 2 and 4/9. One digit, one multiple factor of 9. And 105 repeating was 105 over 999. Whoa, do you see a pattern? I think I do. Here we had, if you have all the digits after the decimal point repeating, all the digits after the decimal point repeating, the number of 9s in the denominator are the number of digits that are being repeated, and the numerator are just the numbers that are being repeated. Ah, amazing. What a cool trick. Okay, so let's fill in this rule. It says fill in the table with the information you found in previous slides. Is there a pattern that develops when converting a repeating decimal into a fraction? Yes, there is. If all the digits to the right of the decimal point are repeating, then the equivalent fraction is the repeating digits in the numerator and the number of 9s equal to the number of digits in the denominator. Perfect. If all the digits to the right of decimal point, all of them are repeating, then the equivalent fraction is the repeating digits in the numerator, 5, 74, 4, 105. And the number of 9s equal the number of digits in the denominator. So just one digit, just 1 9. Just 2 digits, 2 9s. Just 1 digit, 1 9. 3 digits, 3 9s. Excellent. So what I'd like you to try to do is with your group, I'd like you to fill in the table on the next slide. And I'm going to give you 2 minutes with your groups to finish. So please pause the video for 2 minutes to fill in the table on the next slide. Thank you. Okay, let's see how we did. 1 digit repeating, and they're all repeating to the right of the decimal. 8 9s. 2 with 1 9 in the denominator. That means this is 0 point with just 1 2 being repeated. 47 over 99, 2 digits being repeated. 0.47 repeating with the bar over it. 0.25 repeating. 2 digits, that means 2 9s go in the denominator. 4 3 2, 3 digits being repeated. 4 3 2, 3 9s in the denominator. And let's see, 1 2 2 3, 1 2 3 4 digits being repeated. That means you're going to need 4 9s in the denominator. This is cake. Let's keep going, you guys. Excellent. Okay, slide 31. Does the pattern you described and used for the previous slides apply to this one? Well, can it just be 16 over 9? No, because that's going to be bigger than 1. There's only 1 digit being repeated. Oh, no, we can't use our trick. No, not all the digits to the right of the decimal point are being repeated. Just the 6 is being repeated. So this is 0.16666666666. Well, in our notebook, let's rewrite this into a fraction. Okay, let's switch to our notebook. Okay, we're going to use the same process we did before. The first thing we're going to do is we're going to take our decimal, we're going to set it equal to, that's right, x. And if you like to write it as x equals 0.16 repeating that way, that's fine too. So taking a look, what I want to do is I want to multiply both sides by the same number so that the repeating decimal ends up lining up and I can cancel it out. So if x is equal to 0.1 with just the 6 repeating, I can multiply both sides by 10, and then we have 10x is equal to 1 point, and then the 6 is just being repeated. Notice I'm going to write 2 decimal places here because when I subtract what x is equal to, I have 2 decimal places and I want my decimal points to line up when I subtract. So again, I'm going to subtract x on both sides, but remember x is equal to 0.16 repeating. That's such good news that these repeating decimals cancel out. So now we have 9x is equal to 1.6 minus 0.1, 1.5. Now we're going to divide both sides by 9. Oh no, you guys, we have a decimal in our fraction. We can't leave that there. So you could multiply numerator and denominator by 10 to move the decimal place over 1. But notice you're then going to have to do quite a bit of simplifying. So let's think about what I can multiply 1.5 by that's smaller than 10. That ends up with a whole number. Well, why not just 2? So if I multiply numerator and denominator by 2 here, what do we get? We get 3 over 18. Ah, very, very nice. Is this able to be simplified? It is. So 3/18, if I scale down by 3, is equal to 1/6. So that means that 0.16 with just the 6 repeating is equal to 1/6. And we can always grab our calculator and we can take a look. Well, what is 1 divided by 6? Oh my gosh, 0.1 and then the 6 is repeating. Remember your calculator rounds, that's why there's that 7 there. Ah, so we did a good job, you guys. Excellent. Okay, let's move on to the next slide. The next slide has 2.0 and just the 1/5 is being repeated. So from here, let's see what we can do to cancel out and delete that repeating decimal. So I'm going to set this equal to x. Now, do you think if I multiply by 10, I'll be able to cancel out my repeating decimal? I don't know. Let's try it. 10x is equal to, well, that would be 20.15. At least the repeating decimal is by itself. Subtract x from both sides, 2.015. And make sure you're lining up your decimal points. 1/5, that'd be a 1, right? Good, good. Oh, but 1 repeating and 5 repeating don't cancel out. 1515. Oh no, you guys. Is this ever